Hello everyone, we are Group Bim123. Today we want to share a topic which is a case study on BIM implemented projects in Hong Kong. This is our content page. First of all, let's talk about the background of the selected case. This public housing development project, which aims to over 4,000 residential units, is managed by the Hong Kong Housing Authority, and the construction started in the late of last year. The main contractor of this project is Able Engineering Limited, and the subcontractor who is handling building information modeling solution is Workon Limited. Regarding the scope of BIM in this project, there are four main items produced in this project using BIM. The first two items were using Revit to generate 3D models that contain different information. Also, by using Revit work, class analysis was conducted to identify the conflict between different disciplines. The last item is animations. By using Revit work, the videos demonstrating the construction sequence of the buildings was produced.
In this project, the BIM technology has been applied in different usage, including virtual replica, project coordination, 4D simulation, and crash detection. Firstly, in virtual replica, since the drawings are prepared by different project stakeholders, a reference model could enhance the drawing consistency, efficiency, and accuracy. To allow sharing correct information and work in the same project simultaneously, the current BIM technology provides multiple functions and software for project coordination. Hence, it could help the main contractor to duplicate their crash report and progress report. Thirdly, 4D stimulation. By adopting filter analysis work, the execution plan could be stimulated in 3D view with 4D information. In this case, the BIM consultant duplicates a site execution plan through BIM technology for conducting constructability analysis. Lastly, conflict between drawing and specification may cause project delay and cost overrun, so minimizing discrepancy problem before the construction work is carried out could help the main contractor to reduce rework delay and construction defects. In this case, drawing discrepancy, MEP collision, and headroom calculation mistake are the issues found in the crash report.
Firstly, we can reduce, reverse, and save costs by using BIM. In this project, spatial coordination are conducted in hours work. We can check the space of the corridor and the volume of the escalator to prevent spatial conflict. Since the cash will increase the cost for demolition, researchers estimated that the saving cost can up to 20% of the contract value by using the cash detection function. BIM improves coordination and communication. BIM supports the integrated project delivery method, which encourages the early collaboration between the key stakeholders, facilitates multidisciplinary coordination, and quality of work. In this project, the BIM manager has to continuously prepare the cash report by collecting the design information from different project teams. According to the case presented by the researchers, this multidisciplinary collaboration will eventually lead to the success of the project, that the project has a tendency to be completed earlier and the client will be satisfied with the quality. In addition, the 4D simulation can not only simulate the 6-day construction cycle, but also demonstrate the operation of the tower crane. Consequently, the key stakeholders will have a clear common understanding on the construction sequence and the storage location for material. Therefore, the intuitive 4D simulation also facilitates the communication. BIM is also beneficial to planning, scheduling, and time management because the quantities of the works are automatically calculated. This will facilitate the material delivery and workers' productivity so that the project manager is more easy to plan the schedule. Also, 4D simulation enhances the safety analysis for planning the temporary structure and the selection of the safety equipment. For the time management, scholars estimate that the application of BIM can reduce the project time by 7%. Since the master program is only reflects the logical sequence and the duration but without the detailed construction activities, with the help of 4D simulation, the time to perform the works, construction activities, and the cycling arrangement are clearly shown. Therefore, BIM supports the visualization of schedule that can identify the potential issue like the time clash on scheduling. Finally, BIM improves efficiency and quality management. Through its documentation function, BIM manager can find the relevant drawings and model efficiently. In this project, volumetric precast bathroom and semi-precast lab are used. BIM acts as an input data for the manufacturing of the modularization units, which enhance the use of MIC and prefabrication construction. This construction method usually have a better quality control. Therefore, the application of BIM will further enhance the productivity and the quality in the construction stage.
In this case, ABLE are relatively small contractor in Hong Kong. The staff in ABLE are lacking BIM experience and expertise. They do not acquire the necessary BIM knowledge and do not know how to operate BIM software. Actually, most of the contractor firms in Hong Kong are BIM laggers. It is stated as the construction company does not have active BIM projects. Therefore, ABLE does not have an in-house BIM capability for conducting BIM service. In order to improve this situation, BIM training and education are important. For instance, a project-based training process that uses an actual project to train their staff can effectively enhance their practical skill in real BIM projects. Meanwhile, they can join events organized by HKCIC for improving their BIM capability. For instance, BIM workshop and seminar, etc. Also, the development of an in-house BIM department not only can increase the BIM competence and BIM adoption rate, but also can act as long-term policy to foster BIM expertise. The second challenge that I want to discuss is double handling problem. There are not only many clients still require 2D drawing for the submission approval, but also the subcontractor lack BIM adoption rate. Therefore, in most cases, the 2D drawing still take precedence over the BIM model. The project team require double handling between 2D drawing and BIM. This may eventually enhance workload and use extra time for preparing 2D drawing in BIM project. In order to solve this problem, you should change the original practice to BIM lead practice. You should promote and create some specific contract provisions for BIM projects to clearly specify the BIM goals, construction obligations, and the use of BIM model. Developing an appropriate BIM standard and specification for the use of BIM could also help the industry understand how to implement BIM in their project. This can help BIM become part of the major submission format instead of competing with 2D drawing, and let the submission of BIM model become important. Another challenge we find is about IT infrastructure issue. The IT hardware, software, and the network are relatively weak in the site office. A BIM coordinator in this project also pointed out that there is insufficient BIM-capable computer supply to the BIM modelers, so they are required to use their own notebook computer to perform the BIM services. However, this may cause a reduction in productivity and the quality of the BIM services. This finding shows that the general contractor will suffer IT-related issues when implementing BIM in the project. The reason usually is because of the expensive BIM software and IT hardware. So in 2019, the Development Bureau provided financial support (CITF) to the industry. The financial support not only could help them to purchase IT infrastructure, but also provide subsidies for the BIM training and education to the industry practitioner. Therefore, it could help them to develop innovative technology in the construction project.
Next, let's talk about what strategies can do for better use of BIM for construction. There are two suggestions including developing advanced use of BIM and integrated BIM with other technology. The first suggestion is developing advanced use of BIM. This could enhance performance in all phases of management process. For example, 5D BIM benefits construction cost management. 6D BIM helps to conduct building energy survey to achieve nearly zero energy buildings. 7D BIM contains enormous building information that helps to implement facility management. On the other hand, integrated BIM with other technology could maximize the effectiveness of BIM. For example, RFID BIM platform. This can make the information accessible through mobile device. The users can check and manage information in real time. Also, building visualization can be realized to improve construction practice. Another integrated application is 3D laser scanning. Using this technology, as BIM modules can be generated to enhance the information accuracy. BIM also helps in the implementation of MIC projects. It can serve as an information sharing platform to facilitate the collaborations for MIC projects.
We have conducted a comprehensive case study for a public housing project at Twin Moon. The BIM technology used in this project mainly focus on the visualization function, include the virtual replica of 3D model, drawing production, project coordination, 4D simulation for scheduling, and cache detection. We also discussed the benefits, challenges, and the corresponding solution for using BIM. Last but not least, BIM has great potential for more advanced usage and integrate with other digital technology. That is the end of our presentation. Thank you for attention.